Hello. So in this lesson, I'm going to talk about instantaneous center of rotation. And what is instantaneous center of rotation? Or it's also called instantaneous center of zero velocity. We have talked about planar motion of rigid bodies. We said that in its most general form, the planar motion of rigid body is composed of a translation and a rotation. Then we also said that we can describe the motion of rigid body with respect to any point in this rigid body, meaning that we can describe the motion. Let's say if you have a pure translation, obviously omega is 0, and this is not the case we're talking about here. We're talking about the case where omega is non-zero, and then we find this point A, not find, choose any point, and then compute the motion of point A, the translation of point A, and then the rotation about an axis through A. Again, we're talking about planar motion of rigid bodies, and we also said that, just to remind you, omega is independent of the choice of A. Now, question is, what if you find a point where the velocity is 0? So obviously, if you have a pure translation, then you cannot find that point. Because if you have a pure translation, it means that every point in your rigid body translates. So there is no point either in the rigid body or as an hypothetical extension of the rigid body. So we see C does not exist. But let's say we have a case where we have a combination of rotation and translation, and a point exists. So this point where the velocity of the point is equal to 0 is called instantaneous center of rotation. Instantaneous center of rotation, or instantaneous center of zero velocity. And why is it called instantaneous? Is because if you think about a pendulum in planar motion, that body has a fixed center of rotation. So, but in this case, we are talking about instantaneous center of rotation. And why is it instantaneous? It means that by time, this instantaneous center of rotation moves. So it's not a fixed point, it's instantaneous. So now let's look at this body, this rigid body, arbitrary rigid body. Let's say that I'm writing out the equation of the velocity equation for this point P. Vp is Vc plus omega cross Rp with respect to C. Let's say I found this point C. So this point C, because by definition it's instantaneous center of velocity, the velocity is 0. So Vp is going to be omega cross Rp with respect to C. So think about this planar motion. And also think about right-hand rule. So if you think about right-hand rule, your Vp, your velocity of point, is got to be perpendicular to this position vector of P with respect to C, and also omega. Omega points out of the page. So you have P, and we have this body in planar motion. So Vp is also perpendicular perpendicular to Rp with respect to C. So wherever this C is, this Vp has got to be perpendicular to this position vector. Initially, we don't know if this is the C or C is here, for example. All right? Is C here, or C here, or C here? But we know that this velocity is perpendicular to this position vector. So we can say that velocity of P is perpendicular to this line going through the point C. Now, if you pick another point, P prime, for this P prime, it's the same thing. So we have already found point C, and instantaneous center of velocity or instantaneous center of rotation is found for the whole body. So again, same thing for point P prime. So V prime, Vp prime, the velocity of this point, is perpendicular to the line going through the point C. Right? So it is somewhere on this line. So we know that C, the instantaneous center of velocity, is somewhere on this line and also somewhere on this line. So it's got to be at the intersection of the two lines, right? So it cannot be this point, but it's got to be at the intersection of these these two lines, right? So in this way, you can find instantaneous center of velocity. So, and this is the only case we are essentially interested. But by definition, instantaneous center of velocity is a point that rigid body rotates about in that instant of time. It's not necessarily a point in the body, right? It's not necessarily physically a point in the body, but the rigid body instantaneously rotates about that point, and it changes in time, right? So that's about instantaneous center of rotation. Yeah, and all right, so thanks for paying attention.